IP version 4, Unicast, Broadcast, and Multicast. In an IP version 4 network, the hosts can communicate on three ways: unicast, broadcast, and multicast. These three types of communication are used for different purposes in data networks. In all three cases, the IP version 4 address of the originating host is placed in the packet header as the source address. First is unicast. Unicast transmission is sending a packet to one destination IP address. Unicast transmission is used for normal host-to-host communication in both a client or server and a peer-to-peer network. Unicast packets use the addresses of the destination device as a destination address and can be routed through an internet. So in this example, if the PC at 172.16.4.1 wants to send a packet to the printer at 172.16.4.253 only, this type of transmission is called unicast. So unicast is one-to-one transmission. Next is broadcast. Broadcast transmission is sending a packet to all other destination IP addresses. In a broadcast transmission, if a sender is sending a packet, except the sender, all others will be receiving this packet. In broadcast transmission, the traffic travels from a single source to all destinations. In this diagram, the PC at 172.16.4.1 sends a packet to the destination address or to the broadcast address 255.255.255.255. This packet will be received by all devices on the network segment. Last is multicast. Multicast transmission is sending a packet to a multicast address group. In other words, it is a process of sending a packet from one host to a selected group of hosts, possibly in different networks. It means it is not going to send the packet to all the participants. Rather, it is going to send this information to a group of participants or some selected participants. In the example, the multicast address here is 224.10.10.5. This represents the address of the multicast group. So if the PC at 172.16.4.1 wants to send a packet to the destination address 224.10.10.5, all devices wanting to receive this packet can join to the multicast group. Since the laptops at 172.16.4.3 and 172.16.4.4 are going to the multicast group 224.10.10.5, they will receive the multicast packet from the PC, and the other devices that are not joined to the multicast group will not receive the packet. Types of IP version 4 addresses. So there are two different types of IP version 4 addresses, public and private. As defined in RFC 1918, public IP version 4 addresses are globally routed between Internet Service Provider or ISP routers. Public IP addresses are external addresses. It means they are globally unique and valid on the Internet. While private addresses are common blocks of addresses used by most organizations to assign IP version 4 addresses to internal hosts. Private IP version 4 addresses are not unique and can be used internally within any network. It means they are only valid on their local area networks but not on the Internet. Private addresses are not globally routable. In the table, RFC 1918 defines the following address range as private: 10.0.0.0/8 addresses 10.0.0.0 through 10.255.255.255. 172.16.0.0/12 addresses 172.16.0.0 through 172.31.255.255, and 192.168.0.0/4 16 addresses 192.168.0.0 through 192.168.255.255. The addresses in these ranges are not routable in the Internet and may be freely used by any organization for local purposes only. Network Address Translation, or NAT, translate private IP version 4 addresses to public IP version 4 addresses. This is a service that is used in routers, and its purpose is to translate a set of IP addresses to another set of IP addresses. The reason for having NAT service is to help preserve the limited amount of IP version 4 public IP addresses that we have available around the world. NAT is typically enabled on the edge router connecting to the Internet. It translates the internal private address to a public global IP address. In NAT, the router assigns the devices inside our home or business private IP addresses, and when our devices need to access the Internet, their private IP addresses will be translated by NAT in the router to the one public IP address that we have been given. Special use of IP version 4 addresses. Loopback addresses are used for testing purposes. It is to check whether TCP/IP is working properly or not, or for checking the host TCP/IP configuration and services is working properly or not. Loopback IP's range is 127.0.0.0/8 or 127.0.1 to 127.255.255.254. It is commonly identified as only 127.0.0.1. It is used on a host to test if TCP/IP is operational. In the example, you have to go to command prompt and type ping space 127.0.0.1 and the result will appear below. Link local addresses. It has a range of 169.254.0.0/16, 169.254.0.1 to 169.254.255.254, commonly known as Automatic Private IP Addressing API-PA addresses or self-assigned addresses. Used by Windows DHCP clients to self-configure when no DHCP servers are available. This means it can allow two computers to communicate when there are no DHCP servers available. So if you connected two PCs back to back using cable, they'd be able to communicate with each other without the user having to configure static IP addresses on those addresses. The PCs would simply use an IP addresses in this range and be able to communicate with each other.